Okay, we've been talking about gases, and all gases exert some sort of pressure. So we need to start and discuss what pressure is. It's the force from the particles actually running into a surface. So what happens when we increase the number of particles that we have? So if we have a pressure, it's going to be from those collisions. If we increase our number of particles, that means we're going to have more collisions with the wall of the container. The collisions between the particles and the walls are going to increase when there's more, and then our pressure is going to increase. So if we increase how much gas we have inside of a container, the pressure should also increase. Well, what about the volume? Well, if we have, again, pressure from the collisions in our container, if we make that container larger, then we're going to have the same number of particles in that container, but there's going to be more space for the particles to take up. So the traveling is going to take longer. The particles are going to have to go a further distance, so the collisions are going to decrease because it's going to take longer for the particles to travel and hit the container. So if those collisions are decreasing, our pressure will decrease. So anytime we increase the volume, the pressure will decrease. And what about temperature? Well, temperature we talked about is proportional to the average kinetic energy of our molecules. So the faster our molecules move, the higher the temperature is. Kinetic energy is energy due to motion, and again it relates to how fast the particles are moving. So as temperature increases, our motion of our particles increase. So if the temperature increases, we know that our collisions are going to happen more often. Their particles are going to be moving quicker, and so our pressure should also increase. So as temperature increases, pressure increases. Well, what happens inside and outside a container when we change our pressure? Atmospheric pressure is the pressure of the atmosphere. Okay, the layers of the air around us. Well, we typically don't even notice that atmospheric pressure is around us because it's been there our whole lives. We also have air in our lungs that help balance that out. But if we change altitude, if we go higher, there's less layers of air. So when there's less layer of air, then our pressure, or the atmospheric pressure, is going to be lower. So as altitude increases, that atmospheric pressure decreases because there's fewer layers of air. So what happens when we have a container? A container either is going to expand or contract until the pressure inside and outside that container is equal. The pressure outside the container is the atmospheric pressure. So here's an example. We have a bag of chips. Everybody knows that when a bag of chips is sealed, you can see that there's air inside of it. So what happens if you take that bag of chips that's made at sea level and then take it to the top of the mountain? Well, if we go to the top of the mountain, there's less air pushing down on us, so that means the outside pressure has decreased. So the internal pressure inside the bag is going to be higher. The external pressure outside the bag is going to be lower. So if the pressure inside the bag is bigger than the outside of the bag is actually going to expand. Reduces the internal pressure, and it equalizes, and we thus end up with this bag expanding, so it looks like it's going to pop. Well, when expansion can't happen, when we have a rigid container, for example, an aerosol container, we throw that in our duffel bag with maybe hairspray, throw it in the trunk of the car in the summer because we're going to a friend's house and we're going to do our hair later. What happens? Well, same thing. If the temperature rises inside the can, we know the collisions are going to be more often. There's going to be more pressure because of those collisions happen more often. Well, if the container can't expand and there continues to be more and more and more pressure, what's going to happen? Well, the internal pressure gets higher than the external pressure and our container explodes. This is why you do not ever put aerosol cans into a fire because of the explosion that can happen, and then obviously injury could ensue from that. Soft containers or movable pistons can expand and contract, but rigid containers can't. So we have to be careful when we're dealing with those rigid containers.